Hi everyone, I would like to start by welcoming you to COP4931 Advanced Topics in Java Programming. So this is an elective that is offered both to students in the BS in Information Technology and the BS program in Cybersecurity. So we are going to, in the screencast, just try to get you started in the course routine, explain to you how we are going to work together, do a little bit of a syllabus overview. And at any time, if you have any question that comes to mind while you are watching this video, please open up the Canvas site for the course, go to the forum section, and post in I think it's called the Syllabus Question forum there. That is there just for that purpose, for you to be able to voice out all of your questions, concerns about the syllabus and this presentation. So without further ado, let's get started. And we're going to get started with a sort of pseudo-legal disclaimer there. So be reassured, we're not going into real legal disclaimers here. Pretty much the warning here is watching this video doesn't replace actually reading carefully the syllabus. Now, I know syllabi are boring most of the time. However, there are always very important nuggets of information in the middle of the syllabus. And if you just gaze over it and go very fast over it and don't pay attention, you're going to miss those nuggets of information. So the syllabus is a sort of contract, okay? But even more importantly, it's your go-to resource for information about the course. So you really need to take the time to check it out. And like I already mentioned, if you have any question, well, we have a forum for that. So before we dig into what we're going to actually do this semester together, I thought I would introduce myself. So my name is Alessio Gaspar. Here's a little URL here if you are really that curious and want to know more about what I'm doing around here. But I'm going to give you quite a quick overview of my research interest and my teaching interest, okay? The idea behind this is really that as you are taking classes in our program in the Computer Science and Engineering Department here at USF, you need to realize that you should really reach out to the faculty in the department and have little informal chat with them so that each one of us has pretty much a perspective on the computing discipline. We have some areas where we are more knowledgeable than others. And if you talk to enough people in the department, you're going to get that kind of overview, you know, that kind of informal overview of the discipline that might help you figure out actually what you like, what you do not like in the computing disciplines, and what you want to do, you know, when you graduate. So it's really important that you are aware of what each of the faculty in the department is pretty much focusing on, so that you can reach out to them and have those little informal chats, you know, in the hallways or by email, like so on and so forth. It's even more important because if you consider taking a capstone project of any sort, you'll have to find a faculty generally to supervise your project. So if you find somebody in the department that is really working on something, a topic that really interests you, it's a good idea, you know, maybe to do a capstone project with them or an independent study or something like that, okay? A free credit course that allows you to explore a topic that is maybe not covered in the curriculum right now, but that would help you later maybe find a job or do really what you like, okay? So it's in that perspective that I introduce myself in just two slides. I won't take much of your time, just to let you know what I'm up to, what I'm interested in. And if you have any question about those topics, I would be really happy to expand on them during discussions one-on-one and help you get started even in one of those topics if that's your goal. So concerning research, I've been always really focused on artificial intelligence for a very long time now. More specifically, I'm interested in a class of technique called evolutionary computation, where we pretty much simulate natural evolution and we use those simulation as a technique to solve problems, okay? So that's enough for now. Just if you're interested, just let me know and I can talk about that stuff for hours. But that was my original research interest. This is what I did my dissertation in. And then for about 10 years, I switched to computing education research, which is pretty much, it's probably more relevant to you as you take this course. It's a research discipline where we try to understand using, you know, social science and educational research design. We try to understand what makes some aspect of the computing discipline really difficult to learn by student, what is the nature of those difficulty and how we can overcome them. So it's not like it's not the same thing as teaching. Okay, we try to adopt more research perspective. We try to really understand what makes, for instance, programming, such a difficult topic nationwide, where we have attrition rate of 40-50% in introductory programming class all across the nation. So that's the second topic that has been really interesting me in research. And for the last, I don't know, 3 to 4 years, I've been pretty much going back to combining both things. So for example, I try to apply those algorithms that I mentioned, evolutionary algorithm, those evolutionary technique. I try to apply them to generate automatically practice problem for students, or even to generate automatically elements of what we call concept inventories, which are just a fancy word to say we need to find out the catalog of misconception that students come to a given class, to a given topic with. So for example, you take your first programming class, well, it would help us as educators if we had a documented and statistically valid catalog of all of the different misconceptions that you bring to that class when you first start programming, so that we can teach to that. Okay, we can craft exercises that are going to force you to think about those misconceptions, like unveil them, make them obvious, and then help you overcome them. Okay, so that's the kind of stuff I've been doing in my research, and as you can tell, my research is really connected also to my teaching. So my teaching interest, I'm going to just focus on the topics and not the pedagogy. The topics are essentially anything programming. I really love programming. And for those of you who think, well, I really don't like programming, I don't want to become a developer, and this guy is crazy about programming, oh great, this is going to be one of those class, let me clarify something here. I would not necessarily want to be a full-time developer, but I do like studying programming language. I do like teaching programming to students, and I like programming as a craft. Okay, so it's not because you do not want to be a full-time developer and do only programming 24/7 in your life that you cannot actually learn to appreciate the intellectual challenge of programming and the beauty of programming techniques. Okay, so I'm really focused on that aspect of programming, the technique, the tool, teaching it to people and stuff like that. And I like also web technology, but I'm on and off on that, meaning that for 2 years, I'm going to be able to find time to focus on the latest and greatest web technologies. I'm going to learn some framework, play with them, tinker right and left. And then for the next 3 years, I'm going to be very busy with a research grant or something like that. And I'm not going to keep in touch with those technology. And then 3 years in the world of web technology is huge. Okay, so when you come back after that kind of hiatus, you find yourself with a ton more frameworks that emerge and stuff like that. So that's pretty much what I've been doing over the last few decades, like dig in, then dig out, then dig in again and come back, etc. But it's an on and off thing, but this is really a great application for me for the programming technique that I learned. Okay. And this selective actually is going to also show you that kind of stuff, okay? How programming techniques are really relevant, for example, to modern web development. In addition to programming and programming in the context of web technology, I'm also very interested in Linux technology. I've been for quite a while actually, since Slackware and stuff like that, and system administration to a lesser extent. Again, that doesn't mean that I would want to be a system administrator 24/7, but I do like the technology, I do like learning them, I do like teaching them, and I like generally tinkering with Linux system. So, okay, that rounds up a little bit the presentation. I try to keep it short, okay? But again, the main point is if any of those keywords that I mentioned rings a bell, or you're curious, or you don't really even know what it is about, let's use this as a conversation starter, okay? Don't hesitate to reach out to me, and I'll be more than happy to initiate you into one of those fields, or give you some pointers, some readings, and stuff like that, answer your questions. So back to the main thread of this slideshow, of this screencast. We are going to start by discussing a little bit what we are going to study together this semester. So the topic itself, okay, what is the menu for this class, if you will. So the class is an advanced programming techniques class. So we are going to study different styles of programming, different techniques that are used in modern programming language, and we are going to use Java to do so. So the first thing to understand, and this is actually a source of common misconception, so let me grab a pen here real quick. We are not going to just talk about APIs, application programmer interface, or frameworks, okay? Not because it's not worthy. This is actually an interesting part of progressing into a programming language, to learn a multitude of frameworks and know how to leverage them efficiently. But it's not as fundamental. So that means that we could focus on a framework today, and then next semester a different framework emerge, and the course is completely obsolete, so we update it, but then again, the time it takes us to update an entire course on a new framework, maybe it became obsolete, okay? So it's not necessarily that catastrophic in the Java world, in the Java ecosystem of programming language and techniques, but it's certainly something that is really in IT as a whole. Look, for example, at web frameworks, okay? Angular.js, stuff like that, the emergence of Node.js. During a time, and I think it's still going on right now, even though I'm a little bit out of touch lately, during a time, there was an emergence of multiple framework every single, I would say, trimester. It was very easy to just blink and fall behind because there were so many technology emerging, and framework emerging, just even restricting yourself to a single language like JavaScript. The sheer number of frameworks that exist in JavaScript for web development is daunting. Okay, it's for a newcomer to the field, it's really daunting. It's a steep learning curve. Okay, so instead of jumping from framework to framework, from API to API, every semester, I have decided to focus this course on concepts that have proven to be underpinning most of the frameworks that are emerging. So before you delve actually, in the specificities of this or that framework, what we are going to do in this class is we are going to focus on things like, for example, metaprogramming. Okay, so that's a programming technique, and it's a programming technique that is actually what makes things like object relational mappers, for example, a possibility. So what is an object relational mapper? It's pretty much a framework or an API that allows you to make your objects, your Java objects, persistent into a database, for example. Okay, so you create an object, automatically you say this object is going to be persistent in that database, and then you don't have to worry so much anymore about SQL queries and stuff like that. Okay, so it's a layer of library that is going to allow you to very practically and very conveniently bridge your object that exists in the Java virtual machine memory to a database, back and forth, load them from the database, save them to the database without having to go through a bunch of, SQL queries and all those kind of hoops. So again, instead of focusing on this particular object relational mapper, we're going to talk about the principle of an object relational mapper, maybe, and then immediately we're going to say, okay, so what makes it possible? And what makes it possible is a metaprogramming technique. So we're going to focus on the metaprogramming technique, so that when you learn that, every time you go through a new framework that you have to learn and you see an object relational mapper, you'll have an immediate idea of how it's working. And more than that, any form of feature that is going to rely on metaprogramming, you'll also have an idea of how it might be organized underneath, and that will help you learn it faster. The second misconception that I'm going to dispel, so that's the second bullet item here in the middle of the slide, is the focus on Java. So Java is definitely in the title of the course, and it's in the title of the course because we're going to use that language for the entire semester. Okay, so really, to be fair, we are studying, advanced programming techniques like metaprogramming, functional programming, etc. We are doing so really in the context of Java. But you are going to see that I have a way to expand on that in the course. Okay, there's an assignment called a case study that's going to allow you to get broader horizon than just Java from this course. But regardless, yes, there is a big focus on Java. Now, despite this focus on Java, our goal is really not for you to become a Java elite programmer. Okay, we are using Java simply as a way to illustrate the concepts that we're talking about. And that's it. We need something practical, okay? We could talk about the concept all day long and have no practical application, and then you would find yourself still needed to bridge, those lectures to anything useful and pragmatic on your own. So instead of doing that, we start from the get-go with an actual programming language. We illustrate each of our concepts by code. So it's going to be very much a hands-on course where we show exactly what you can do with the concept from the get-go. Okay, so that's just a matter of personal preference. That's how I really like to learn, and I hope that it will work for you too. Now, last point on this slide. Yes, I mentioned that the goal of this course was not to make you a Java pro elite programmer, super knowledgeable in Java. This being said, don't misinterpret what I'm saying here as meaning, well, Java doesn't matter, or, it doesn't serve you well to actually try to dig deeper in Java. No, absolutely not. Because we use Java for the entire semester, I expect that by the end of the elective, you'll be in a strong position, if you wish to do so, to pursue a certification in Java. Okay, so you'll still have to do some some studying on your own, because we are not trying to prepare you explicitly for a certification in Java, but this is something that might be worth considering if you're going to do any sort of development, just to add on your resume, one or two entry-level certification pertinent to the fields in which you want to find a job, okay? It's a very good idea as you go through the BSIT or BS in Cybersecurity program to get your education at USF, so get your degree at USF, and in parallel, maybe get one or two, entry-level certification, like I said, that are going to add up to your resume. There are three things that are really looked at for a candidate, a strong candidate. It's the education, the certification, and the experience. And as far as experience goes, we have capstone projects. So even if you have not worked in IT yet, you should be able to do a capstone project at the end of your program that is going to allow you to work on something that is directly related to what you want to find a job in, okay? So for example, if you want to become a system administrator, I would really advise, again, doing a web application as your capstone project. Now, try to find a faculty that is teaching system administration, that is interested in system administration, and work on an interesting project with them for one semester, so that when you go to your job interviews, you can show your degree, your education, you can show your certification, and you can show at least some experience, hey, this is the kind of thing I can do on my own, working 6 months part-time. And that gives an idea to your future employer about, your capacity, your practical capacities, okay? So that's pretty much the general idea of what we are going to study this semester. Now, onto the details. So what you have here is a very rough outline. There is a slightly more detailed outline in the syllabus, okay? But this is really a list of the topics that we are going to cover in this elective. So the first thing we are going to do, and it's going to take us about, and this is approximation, okay? It's going to take us about 2 weeks. The first thing we are going to do is we are going to do an accelerated review of Java programming and OOP fundamentals, okay, object-oriented programming fundamentals. That's pretty much a prerequisite from this elective. You need to know how to program in the programming language of your choice, preferably Java, but if you learn another language, that's okay. You'll be able to jump into Java pretty fast. And you need to know what object-oriented programming is about. So you need to have those base concepts. Why? Because we are going to build very fast on top of this. So to avoid, having people taken by surprise and jump directly into the difficult stuff and lose half of the class, I have this little review here that's going to help us, kind of warm you up for the rest of the course, prepare you, or even just allow you to self-evaluate whether the selective is really for you, okay? If you have tremendous issue during that part of the course, warning, okay? Something is probably not going optimally there. You need to come and talk to me. We need to assess, whether you are ready to take the elective or whether it's better for you to drop out of it and then take it back maybe when you're more ready, pretty much. All right, once we are done with that part, then we are going to dig into the different sections that bring new information that you didn't study previously, okay? So once we are done with this little review, we are going to jump in topic number 1, metaprogramming. So metaprogramming is pretty much a set of techniques that allow a program to get data from, to read data from itself. So for example, a program can ask itself at runtime, hey, what are the classes that are defined right now in the JVM? Oh, wait a minute. Here's an object. Can you tell me what is the class of that object? Okay, can you tell me now if that class has a method that starts by, for example, the name test something, you know? These kind of questions are part of metaprogramming. They're part of introspection. The code is looking at itself. And then the second aspect of metaprogramming is intercession, where once you, for example, you take an object and you figure out, okay, this object belongs to class something. And the class something has a method test equation, for example. And now that I have successfully, you know, introspected my code and figured that information about that object at runtime, now I want to call that method on that object. That would be acting on that data. So metaprogramming is really the art of writing code that reads and how to say, act on itself. Okay, so it's really fundamental. We're going to spend about a week on it because we're going to look at basic techniques, and the basic techniques are not that bad. They're not that difficult or complicated to learn. But this is really something that is a super hot topic, I would say, insofar that it is metaprogramming techniques that have been enabling a lot of the modern frameworks that we all enjoy, like Hibernate, Spring in the Java world, you know, stuff like that. So it's really something that I hope is going to be relevant to you in the medium to long term, as you have to learn more framework or you're confronted to technologies, you know, that use those modern language feature. Well, most of them should be stemming from that kind of technique. Then we're going to talk about generic programming and collection. So in Java, it's best if we study generic programming a little bit and before to even use the Java collection framework. So I'm expecting that most of you already used some form of Java collection, whether you use list, array list, map, hash set, stuff like that. Okay, so maybe that's part of what you cover in your object-oriented programming course that you took a while ago. So we're going to revisit those collections. We're going to try to both provide you with a review if you didn't, you know, see many things about collection in the past, and at the same time push a little further. In order to push a little further, we are going to look at the generic programming aspect of collection. So that's why I'm saying those two topics here are really kind of linked together. The more you know about generic programming, the better you understand Java collection, and the better you are at leveraging them, okay? So generic programming is pretty much, has been introduced to allow us to write very nice collection for programming language. So I'm not going to spend more time right now on this, okay? This is probably one of the toughest topics we're going to cover in the selective, generic programming, okay? So we'll come back on that. And then functional programming. Functional programming just because nowadays nobody should go and seek a job without knowing anything about functional programming. So it's really, I mean, in the department here at USF, we do not have, I don't think we have even an elective on functional programming, let alone a core course. It's a topic that is breached maybe here right and left, you know, in some of the core courses, but mostly for computer science students. So for the BS IT and BS cybersecurity student, this is going to be probably your one opportunity to be exposed to some of the very basic concepts of functional programming and see how they work in Java. So first thing I should put as a disclaimer, Java is not a purely functional programming language, okay? So we are going to learn to do what some people refer to as the next generation of object-oriented programming, which is mixing in object-oriented programming with some element of functional programming languages, okay? So we're going to learn that with Java 8. So we're going to stick to that version of Java for this course for now. So it's not going to be a pure functional programming class. It's certainly not going to be about the theory of functional programming, but it's just going to show you how functional programming makes life easier for programmers in certain for certain tasks. Okay, that's our main goal. We want to give you something very pragmatic, a very pragmatic introduction to functional programming, so that you know how to recognize it, you know what it can do for you, and you know hopefully how to leverage at least the basic features of it. So if I try to sum up, these are the 100% new topic. We have at the end a little review week to help you get ready for the final. It's synchronized with the USF official reading days, so that's not a problem. But what is highlighted in yellow right now is really the most innovative part of the course compared to what you took before. Okay, in the collection, like I said, in the collection section, we'll try to go beyond the basics, but still it's going to be mostly a review of things that you have seen before. But those three sections, meta programming, generic programming, and functional programming, these are really the reason for this course. These are the three main programming techniques that we're trying to get you familiar with, and we need the review of Java OOP fundamental, and then this chapter on collection to enable us to dig efficiently into it. And then you have this little warning sign here. Well, yeah, like I said, generic programming is actually the toughest topic of the three, so be prepared for that, okay? We are going to tackle it mid-semester, so that's good. That means that, you know, we're not going to rush onto it at the end of the semester. We're not going to start immediately by the hardest thing. So in the past, when I've been teaching those topics, I've been kind of like feng shuing, you know, a little bit the order in which we study those topics to come up with this outline that you see right now on the slide, so that, you know, we have this kind of like nice difficulty ramping up at the beginning, and then we study generics, and then the difficulty kind of like taper, and then we have this curve. So if this is it's a very scientific graph, right? This is a difficulty, and this is time in the semester. So you should have something like that, right? So hopefully that's going to be true for most of you. But I want to give you a heads up so that you know when to expect that you will have to do a push. If the rest of the course is easy for you, then you'll probably just have to do a push on generic programming. A related, frequently asked question: will we use a textbook? Yes, we will use definitely the textbook. As a matter of fact, I've experimented with different textbooks and tried to get feedback from students to see how well they were working for this class. This is the one that students had the most positive feedback on. This is Core Java for the Impatient by Kai Horstman. The good thing with this book is, if you are a little, weak in programming, or you took your programming classes a long time ago, and you don't remember them that well, or maybe you never took Java before and you took over a programming language and so on and so forth. Well, the advantage of this textbook is that it tries to teach you advanced Java programming techniques, assuming that you know already how to program, but not necessarily that you already know Java. So there are chapters that are going to be assigned in this course that map directly to our modules, to our topics, okay? But you are going to find, if you just peruse through the course, that there are other chapters that are just there to help you, for example, catch up quickly with Java. Okay, this kind of stuff. So really, it should be a book that is good at holding your hands if you need a little bit of hand holding at the beginning, and ease you into the more advanced topics. Okay, so that's why I selected that. Now, we are not going to rely only on the textbook. Okay, we are going to use a lot of web sources of information, because they are free, because generally they are very up to date. So I'm not really into Googling blindly for stuff, but there are some sources of information on the web that are totally legitimate and that you can rely on. For example, we are going to use a large section of the Oracle official Java tutorial, okay? Just because this is the piece of information about Java that is generally the first one to be updated. When there is a new version of Java coming out, this is one of the very first source of documentation that is easily human readable that's going to be available. So we kind of try to stay at the edge there of available documentation by relying on that official website. And then we use also occasionally Stack Overflow and IBM Developer Works tutorials. So Every time I use one of those resources, I will put the link on the corresponding slide, okay? It's a good idea to just explore it on your own. As you review the slides after listening to the lecture, go to that URL, check out the content there, go kind of do a little bit of extra reading around the topics that we cover on the slide, okay? That's why I provide you with those URL. Now, if you are really interested in programming in Java in your future, either full time or Java is going to be a big aspect of your day-to-day work, then I would recommend, by the same author, Kai Horstman, this 2-volume series on core Java. Okay, this is one of the most authoritative. It's really following pretty much the structure of the Oracle Java tutorial. Okay, but it's really one of the most authoritative reference volume on Java technology, core technologies. Okay, not specific frameworks. And then last but not least, I should mention that because the first version of the material that is used in this course was based heavily on this textbook here that shows to the right, Functional Programming in Java. This is an excellent book that is going to be actually the basis for our functional programming section of the course. You do not have to purchase this. It's not a mandatory textbook. This one right here is, okay? But if you are curious, if you really like functional programming in Java, you want to learn more, then I recommend you check it out at the library or something like that, just to take a quick look. And if you like it, well, then by all means, feel free to get it. The author is actually somebody that you are going to, if you do a search on YouTube, you're going to find a wealth of presentation from Venkat on YouTube. He's an excellent orator, is an excellent presenter, very clear, very dynamic, very motivated, and you can find a lot of the stuff that we are going to cover in this course also expressed differently in different contexts, by him in different venues. Okay, so Google Tech Talk, I think he did a Google Tech Talk. I would assume you can find all of those videos from Venkat on YouTube, and he's really well worth listening to. So again, if you are going to stay around in Java, then this is a name that you should be familiar with. So let's talk a little bit about, you are taking an elective. It's a programming elective. First, I would hope that most of you are okay with programming. Okay, and again, being okay with programming doesn't mean that you love programming, you want to do only programming in your career. No, that just means not being afraid of programming and not trying to really avoid programming courses and any tasks that involve programming. Okay, if you are in this situation, this is probably not the right elective for you. That has to be clear from the get-go, okay? We are definitely going to focus on programming technique. If you don't want to do programming, you don't like it, then that's going to probably be wasted on you, and you are going to have a bad time, going through all of that material. So this is fair warning, to put in perspective this course. Now, if you are not allergic to programming, again, even if you don't want to do programming as your main professional organization, you might be wondering right now why, we are going to focus on those different types of programming: meta programming, generic programming, functional programming, in the context of an IT program. Okay, an IT program or a cybersecurity program, since these are the two programs in the computer science and engineering department at USF where this elective is being offered. Okay, so to address this legitimate concern, okay, I need to do a little detour here. So first, we're going to talk about ACM, and more specifically, we are going to talk about the special interest group for information technology education. So first thing, ACM. ACM is Association for Computing Machinery. This is actually one of the two main professional organizations for all computing discipline. Anything from computer engineering to software engineering to computer science to IT to cybersecurity and so on and so forth. Okay, so if you have never heard of ACM or IEEE, I would recommend that you do a quick Google search on these guys, okay? It has benefits for you as an IT professional to be member of such professional societies, okay? They give you a good way to network, a good way to stay in touch with other professionals in the field, and a good way to also get training and resources to keep up with new emerging technologies. And these are not the only things actually that are going to help you in those kind of endeavors, okay? If you consider user groups, like for example a Java user group, a Python user group, a Linux user group in Tampa or wherever you are, going to the meetings regularly of those user group is also an essential part of keeping up with technology, okay? So the reason I'm mentioning all of this is that in previous times where I taught these kind of courses face-to-face, I would do a quick little survey in the amphitheater to see how many students heard of ACM, how many students heard of IEEE, and very few responded every time. So this is why I'm introducing this little heads up here in the slide. Now, we are going to look at ACM because ACM has a special interest group, a SIG, that is really related to us. It's related to IT education. But don't let yourself be fooled by education. They are not only interested in education technique for information technology. They are also interested in defining the IT discipline. And this group is really closely working with both the academic side of IT and the industry side of IT. Okay, so this is why it's probably very relevant for you. And ACM SIGITE has actually released several different model curriculum that are used nationwide to help shape, how we teach IT and what kind of course we put in our IT courses, throughout the nation. So this is in that context that I'm introducing to you the following. The following is a simplified model of what the IT discipline, so both from the academic and industry perspective, what the IT discipline looks like. Okay, so the purpose of this diagram was to really easily explain to people that there are pillars. Okay, there are 5 different pillars that are the foundation of anything information technology. These are programming, and yes, surprise, a lot of students in IT think, well, IT is about system administration or cybersecurity or help desk support, etc. And they think, oh, programming is for somebody else. No, actually, programming is a skill set that is expected from IT professional. Not necessarily to be, again, software developer full-time, but to be able to write script, to do things pretty much, to tell the computer what to do. That's really what programming is about, right? So you cannot simply do an impasse on programming and just not learn anything about programming and be an IT professional that's well-rounded, okay? So networking, that one most people expect it in IT. Human-computer interaction, that's another hot topic in IT that is very seldom known by students. So being able to design user experience and user interfaces that are actually efficient, that are usable, is actually also part of IT. Databases, and of course, web system. And then on top of those pillars, you have 2 different things: professionalism and information assurance and security. So why are those things, like this on top of the pillars here? Because they are pervasive to all of those 5 topics. For example, if you say I'm a security expert, there is going to be a question at some level about what is your expertise in. What I mean is that if I meet a candidate for a security position and I ask this candidate, well, we want to hire somebody to secure our Java application. And the person says to me, well, I'm not a Java developer. So then you cannot do anything related to security really pragmatically with our application. Okay, so let's move on to the next topic. We have this database, and it's connected to a web system, and we are afraid of SQL injections. Well, I don't do really system administration of web servers, and I don't know much about SQL, blah, blah, blah. Okay, so where are we going with this? To be knowledgeable in security in general is good, but you have also to supplement that knowledge, that general knowledge about security policies, etc., with specific technical knowledge that enables you to secure an application or a deployment on a server or things like that, or to do penetration testing, or to find exploits, etc., or understand even the exploit. All of that is going to rely on those 5 pillars that we already discussed. Okay, so make sure that you are, for example, a security professional if that's what you like, but at the same time that you understand how security relates to programming. AKA, if you have to write something, some code, or analyze, audit some code, you need to be able to tell good code from bad code. Same thing for networking practice, same thing for setting up your LAMP stack or Node.js stack, web system, same thing for database. All right, so this is why those topics like professionalism and information assurance and security are kind of like covering everything in IT. They are embedded actually in all of those core topics that we discuss. Now, if you are comfortable with that 5 pillars definition of IT, then the next step is, well, where does programming fit in all of this? And more specifically, where does the kind of programming technique that we are going to discuss in this elective fit? So the overlap with programming, yes, it's a joke, okay? It's like close to 100%. It should be 100%. So the yellow bar shows how much we overlap in this elective with each of the pillar. Okay, so the first pillar, yeah, this is a no-brainer. This is a course about programming technique. Of course, it is relevant to that aspect of IT. Networking, not so much. Okay, to be honest, there are some cases where you are going to have to, for example, update a lot of routers and you are going to write a script to do so. But are you going to use the advanced techniques that we discussed in this course? Probably not so much, or at least for the foreseeable future. Human-computer interaction, yeah, these are not, by the way, scientific estimate, okay? The bar being here instead of here or here is just more of a visual thing than actually a solid number like 50% that has been, tested and proven to be exact. So I would say that the overlap of this course is medium to high actually with human computer interaction topic, because any framework that is allowing you, for example, to develop user interface or to develop most likely, like a single page application. Nowadays, a lot of stuff is web oriented, or even like development of application on mobile system like iOS or Android. All of those tasks are going to rely on framework, modern framework, and those modern framework use actually the technique that we are presenting in this course. So actually, maybe I've been a little conservative here. The overlap is, in my opinion, quite considerable. Database, much smaller. Okay, maybe I've overestimated database and underestimated human-computer interaction on this yellow bar system here. So database is going to be less directly relevant. Object relational mappers are definitely, ORMs are definitely a technique that uses metaprogramming, so you might be able to make a strong connection there. There are object-oriented databases, so there is also a little bit of a connection there, but it's not as pronounced as, let's say, for programming and human-computer interaction, HCI. And then there are web systems where this is, again, pretty heavily relevant. It's really difficult to do anything in web development that doesn't involve at some level some metaprogramming, even if the metaprogramming is embedded in a framework, that involve at some level some functional programming and stuff like that, okay? So for those of you who are interested in web development, this is going to be, again, a very relevant elective. Now, to summarize, the topics we are going to talk about, well, we're going to talk about functional programming. And this is, like I already mentioned, a topic that is a very hot topic right now. It's making a big comeback. So functional programming has been around since probably the 60s, I would venture to guess. But what's happened since the 60s is that we stopped pretty much following Moore's law in the development of CPUs. So the idea was that the processing power of a CPU, the number of transistors in a CPU was doubling, I don't remember, every few months or every year or something like that for a very long while. So we had this progression where the CPU was becoming faster and better, very rapidly. Okay, and then things have been stagnating, maybe you have maybe noticed for the last few years, okay, where the main source of improvement in the CPU is not anymore to overclock it to higher frequency rate. It's not really the processing power of the CPU itself, but it's the number of cores that it can hold. So we have moved away from improving a CPU simply by just improving its one core to a world where, well, yeah, we can still improve a little bit the core itself, but really to make a difference, we worked on ways to introduce multiple cores and more cores into CPUs. The problem with that is that if you write a Java application or any application in any language, and you write it the good old traditional way where it's just running in one thread of execution, then you are using one core. So there's the super, i9 desktop, and this is going to sound old very fast because I'm referencing a current technology, and in a few semesters probably that video will sound very old, but whatever. Let's talk about i9 for now. You have this new i9 multi-core CPU in your desktop. Well, if you are running an application that only uses one core, then it doesn't matter that you have more and more cores available to you. So that put the pressure on software developers to start writing applications that use multiple cores on a CPU. That's called parallel programming, concurrent programming. There's slight little difference there. We're not going to talk about that, but pretty much it's a way to write your code so that multiple things are executed concurrently in parallel. And when you start doing that kind of programming, you are going to very soon feel that the basic programming that you have done before to start doing concurrent programming was very easy in comparison. Okay, concurrent programming has very, very nasty bugs. We could spend an entire course, just discussing about concurrent programming techniques and the pitfalls to avoid and stuff like that. So that's not the objective of this course. But suffice for you to say that concurrent programming is hard. And it's so hard that over the last few years, certainly within the last decade, people have started to realize that if they were adopting functional programming techniques, they could actually, in some cases, automatically parallelize their code. Or at the very least, they could make it much easier to write concurrent application by using functional programming techniques. So I'm not going to dig into the details right now. We have actually 5 weeks of material, dealing with that. But I want to give you an idea of why we care about functional programming. With the advent of multi-core processor and multi-core seeming to be the way to go for the foreseeable future in terms of improving performance, right? You need to write concurrent application, and that's something that's easier to do if you know about functional programming. So that's my little, in a nutshell, introduction. Another thing to consider that makes this course relevant is we are going to focus on Java and those advanced techniques, right? So every time you hear about a new language like Groovy, Scala, Clojure is another one that emerged not so long ago. All of those new languages that become really fast, really popular, and some of them become completely forgotten in a matter of years. All those new modern OOP languages that emerge, they are easily relying on techniques like metaprogramming and functional programming and generic programming. And they are also generally based on the JVM ecosystem. So they run on a Java virtual machine just the same way that Java runs on a Java virtual machine. So learning about those techniques, programming technique, and learning them in the context of Java is kind of a way to help you when you are going to pick up a book on Groovy, and you're going to realize that the authors generally spend most of the book saying, oh, in Groovy you can do this way, in comparison to Java, which does it that way. So if you have never been, exposed, to the way Java works, to how Java implement those features like metaprogramming, etc., a lot of the efforts spent by the authors of those books on new language, a lot of those efforts that are spent trying to tell you how things are better than Java are going to be lost on you, right? Because you never went through Java. So that's another aspect that makes this elective relevant as well, is you are going to have this kind of basic overview of those programming techniques in Java, and this is kind of like a universal language, nowadays. So when you go to a more modern language or something like that, a new trend, you are going to be able to understand what people are trying to improve in those languages because you have been exposed to basic Java. And then, as I already mention. Web language, web system, yes. Web language and web framework, JavaScript frameworks and stuff like that. All of that relies heavily on functional programming, meta programming, so this is going to support your learning of those topics. All right, so we're pretty much done with this this overview of what we are going to actually try to focus on in this course. Now let's switch to how we are going to study for this course. So this section is there to really give you advice, okay? Give you advice on how to make the best out of this course, how to stay on top of the pace that we are going to adopt, the routines that we are going to go through, okay? So I want to give you a heads up, and I will follow up with you every week. So as soon as you don't understand why we're doing something or how you should work on a specific lecture or topic, don't hesitate to reach out to me, okay? This is not meant to be the end of the discussion, the slideshow. It's meant to be the beginning of it. I give you a heads up, but then I'm available every week to discuss with you the specifics. So one of the reasons for which I decided to introduce a free slide, and I do that in most of my course regarding study habit, is I had in the past students that came to me and asked me some very basic questions, but that are fundamental. For example, I had a student in, I think it was a 2000 level class, that asked me, well, it was an online class, how do I take notes while reading the textbook chapter that you assign us to read? What do you mean by taking notes, okay? And the point of the student was, do you want me to actually act like a monk, and transcribe everything that is in the chapter? They didn't see the point in that. Their argument was, the stuff is already written in the chapter. Why would I have to write it again on a piece of paper? Okay, and you can see the logic in that. Okay, there's some sort of common sense logic, but the problem is that sometimes common sense plays against you. Okay, when you try to apply common sense to common things, it's okay. When you try to apply something like learning, an academic discipline or programming or something like that, technology, it might fail you actually because it's an oversimplified view of the problem. So when you watch a video lecture, when you read an assigned chapter in a textbook, yes, it's not enough. Reading and watching are not the same as studying. Okay. Otherwise, every single person that can watch the Discovery Channel would have nowadays a PhD in, quantum mechanics. That's not the case. I can watch a documentary on quantum mechanics and I can even feel comfortable and think that I understand everything. Why? Because the authors of the documentary have been putting a lot of work in trying to be clear, in trying to choose examples that make sense and explanation that make sense. So they did all the work. I'm sitting back, I'm watching this, and it feels good, It feels like, oh, wow, this makes sense. But that is not studying. That is totally passive. Studying is an action. Studying is the act of actually not only absorbing knowledge passively like that, that's the first step, but then questioning that knowledge, questioning your own understanding of the knowledge, asking questions to yourself, and if you cannot answer them, ask them to the TA, ask them to the instructor. Okay, if there is a code example, for example, in one of the lecture, it's not enough to just follow the video and see that the code is working, or it's not enough to download the code or retype it and click compile and run and see it's working. No, you have to modify the code. You have to play around. Why do I have to do this? Okay, that level of deep questioning of the material is essential to learning. Why do I have to do things like that? Couldn't I do it differently? Try it out. Try to modify the code. It works. Congratulations. It doesn't work. Now you should have a question to ask. Okay? You see how this is working? So it's really important that from the get-go, I give you, this is probably the best advice, for any course whatsoever. Start asking questions to yourself while you study, and then the ones that you cannot answer, or if you cannot answer, you can answer it, but you're not sure, then ask questions to your instructor, to your TA. Do not simply absorb knowledge passively. Okay, interact with the material, interact with the people that are there to teach you the material. Second thing I'm going to talk about is the format of this course. It's an online course, but we are following the traditional format of a USF course. Okay, it's not because it's online that there is less material. So in a traditional USF course, you have 2 lectures per week. Each lecture is 1 hour and 15 minutes. Okay, so again, while I will try to chapter the videos so that you have an easy way to jump into them, that's a very good thing, because that allows you to, if you want to review a part of the video that talks about topic X, if I have a link in the video that says, hey, you can jump to 25 minutes and 3 seconds, and this is where we start talking about topic X, that's convenient. That's a really good thing. So that's why we segment the video in that way. But the lecture itself is still 1 hour and 15 minutes. So there is no way to distill the same knowledge by just sticking to a 10-minute video. Okay? So if I want to switch away from having a 1 hour and, let's say, a 1 hour lecture, I could break it down into 10-minute video, but there would still be 6 of them. So one way to do that is to have 6 10-minute video that are separate, or to have a 1 hour video that is chaptered into 6 chapters, with convenient links for you to jump at, the moment in that video where we talk about this topic. But that's one of the fundamental thing I want to explain, because a lot of people come to online class and they say, well, I thought that in an online class I would have to listen only to 2 or 3, short videos, like 5-10 minutes, and that would be it for the week. No, absolutely not. This is still a USF course, so we have some expectation about the amount of material that we are going to cover every week. Okay, so there are going to be the equivalent in this online course of those 2 lecture sessions every week. Some weeks we are going to use the second, what would be the second lecture session to do some hands-on exercise or review or stuff like that, something more interactive. But that's pretty much the first warning. If you expected to have an online class that would take only 2 hours of work per week, it's not going to be the case with this one. Okay, maybe it's the case with others. I don't know. I don't support that, but because it's bad for your education. But I just want to be honest here. You are going to have to expect that we follow the USF standard. So for a 3 credit hours course, USF says you should spend a total of 12 hours per week. So that includes about 3 hours of lecture. Okay, and then that includes plus 10 hours of pretty much homework, reviewing the lecture, taking notes while watching the video, asking questions, coming to office hours and stuff like that, okay? And this is the second bullet item here on this slide. So those 10 hours here outside of the lecture are personal study work. Personal doesn't mean alone. Okay, you can study the lecture materials, the reading assignment with other classmates. You can come to office hours, you can ask questions on the forum. I'm going to go over all the ways you have to get help in this class, okay? So there are things here to help you. But that means that this is where you take the initiative. You ask the question, you don't just sit down and wait for some knowledge to be inserted forcefully, in your brain. So if you find yourself spending less time than that, you're probably not doing it right. Come and see me immediately. Part of what I'm here to help you with is also your learning routine, right? So if you tell me, I really don't know how to deal with the lecture, what should I do? Well, I will walk you step by step. I will help you develop a very solid learning routine. And this is actually going to be very useful when you are actually working on the job, because in our technological fields, you are going to learn new technology on a regular basis. If you don't, you're probably going to be very fast non-employable anymore. So you have to keep up with technology and new things that pop up all the time. And part of being able to keep up is part of being able to learn. All right, so learn from a book, learn from a reference material, learn from a tutorial, a video on YouTube, a course on YouTube, or Coursera, or stuff like that. So we are going to help you develop those good learning techniques here. So don't hesitate to reach out. It's not a problem if you don't know how to do it right. It's a problem if you don't know how to do it right and think that you can get away with it and then wait for too long in the semester to come and ask for help, okay? So as a joke here, that means like you cannot just like move into my office, bring a sleeping bag and stuff like that and stay all the time in my office, but use the office hours, okay? They are there for a reason. I know this is an online class, and for most of you, it's going to be inconvenient to come to campus. Don't worry, I got that covered. If you cannot meet me on campus during the official office hours, we'll have a way for us to meet online. And I've been very accommodating in the past, with the time. I always use that as an anecdote. One semester, I had one student that had a very, very complicated work schedule. We ended up meeting at 1 a.m. Okay, that was a one-off. I don't do that on a regular basis. But my point with this anecdote is to let you know that you are going to have all sorts of problems during an online class, time management, juggling your work with your study, etc. But the worst you can do is to assume that the instructor doesn't care or is not willing to try to help, okay? And so when you deal with problem, when you deal with frustration, get in touch with me. Send me an email, and most of the time we can work out something, okay? All right, so let's go over the different things that you are going to have to deal with in this course. So we divide the course roughly in modules. The modules are the topics that we covered, a few slides ago. So generic programming, review of OOP in Java, stuff like that. In each module, you are going to have some study material. So I already told you the study material is formatted like a traditional USF course, just adapted to online. So you are going to have roughly the equivalent of 2 lecture sessions per week worth of videos. In addition to those, there are going to be reading assignments. So generally, the reading assignments are linked directly from the slide. I will post a copy of the slide on Canvas, okay? So you are going to be able to see, for example, that this slide comes from this reading material, and I put a link, and I will try to underline during the videos, which resource are really a must-read resource, and which one are like, well, you can just, consult it if you want to know more about the topic, okay? As I already mentioned, don't just consider that listening to the video once means you studied it. No, listen to it once maybe to get an idea of what we're talking about, and don't hesitate to replay it, even if you replay it, 1.25 times the speed to go a little faster, but replay it with the pause button easy to reach, so that you can stop, take notes, rewind, do this kind of stuff, okay? That's really what studying is about. And then play with the code examples that I'm going to give you hands-on. So retype them, okay? It's no point for you to download it and just run it. That doesn't bring anything. Type it, make mistakes, make errors, see the compilation error message that you get, and learn from that as well, okay? This is how you learn hands-on. And then, of course, look for questions as you do all of that, okay? And then what do you do with those questions? Well, excellent question. Thank you for asking it. So, office hour, post them on the forum too. This is an online class, so I try to make it as convenient for you if you are studying, at let's say 9 p.m. to be able to actually get that question that you have out of your system and put it somewhere where it's going to be answered. So as I'm going to explain later, generally we try to keep emails, one-on-one emails for personal matters, okay? But if you have a question on anything that is not graded, okay, not an assignment or something like that, a homework, but a question about the lecture, a question about a reading assignment, any question about the study material, right? You should be able to post them on the forum. Don't be shy. This is a learning community, okay? Nobody is going to laugh at you because, they think your question is easy. I won't let that happen, actually. If somebody is starting to be toxic on the forum, I will take care of that, trust me. I want those forums to be open-ended. It's 9 p.m., you have a full day of work behind you, you have a question, you post your question, you realize 5 minutes later that you had the answer to the question. Big deal. That's not a problem at all. Just post again and say, oh, never mind, I figured it out. You know what? If you figured it out wrong, when I get to the forum, or if another student gets to the forum before me and sees your question and see your problem, we'll point that to you. That's the key. Okay, the key is that not only you can ask for things that you don't know, but you can ask also for things that you think you understand so that they can get double checked. And that brings me to another important aspect of forums, and that's why we use forums for questions about the study material instead of just, one-on-one emails, because they allow everybody to jump in. Everybody to jump in is called peer learning. So bad peer learning is when an instructor says to the student, well, go ask your question on the forum, and then the other student will answer the question, and I'm not going to check anything. That's bad peer learning. That's not even peer learning, okay? The way we do peer learning is, I ask you to post your question on the forum about the study material. Remember, nothing about graded stuff, okay? It's not a way to get people to do your homework. But you post question about, what you don't understand in the lecture, or the example we use in them, or the reading assignment. And then I want all of you to keep an eye on those forums. You can very easily, in Canvas, subscribe to a forum, so you get an email every time there is a new post. Keep an eye on those forums. If you see a question from another student and that question seems trivial to you, try to answer them. Not necessarily because you are altruist. If you are an altruist person, if you are generous with your time, I mean, that's great. But even if you are not, you're not able to devote your time trying to teach others, I perfectly understand that. In that case, let me explain to you, the benefit for you is that you think you know how to answer the question. If you answer it right, I will confirm that to you, because I will go on the forum regularly and I will answer the question and I will take a look at people who try to answer the question and I will correct them. So you get, if the question was trivial to start off with for you, you get a way to double check that you actually are right and that this is indeed trivial for you. Now, if you get it wrong, if you look at a question from a classmate, you say, oh, this is easy, you type an answer, and then I realize that you're completely off track, then that will allow you to get feedback from me and therefore understand that you understood something wrong. And this is essential, right? When you read the textbook, when you watch a video, it's really easy to be trapped in that confidence feeling where everything makes sense. But then again, how are we going to make sure that you understand the topic at hand? It's by you asking questions, by you trying to answer other questions. Pretty much it's by discussing all together about the study material. That's the only way I am going to be able to detect that deep down, a student that is taking my course online has a misconception. It's when he or she is going to voice that misconception openly and give me a chance to correct. So you see, there's no stupid question in those forums. There's nothing that you should be ashamed of. If anything, you give yourself and myself the opportunity to correct, misconception before actually exams. And that's exactly what we want to do, right? Okay, so now let's say that you look at the forum and you read a question from a peer. And there are really two situations that can happen, right? The one where it's trivial, we already talked about that. Or maybe you read the question from your classmate and you are, what is she or he talking about? I didn't even see that in the lecture. I didn't see that in the reading assignment. Bingo, that's another benefit. By just keeping, up to date with what's going on in the forum, you are going to be able to have other people point out to you things that maybe you missed, okay? And this is an endless problem, okay? For example, if I make a video to say, don't forget to close the door, when you exit that lab, and then you miss that aspect of the video, then I could post an announcement that say, don't forget to close the door when you exit that lab. But then maybe for the same reason you missed it in the video, you're going to miss it in the announcement. So then I could put a reminder, and then I could put a reminder of a reminder. The bottom line is like, yes, when you study, when you watch a video, when you read, you are going to miss things. But the solution is not to make more video or more reminders or more announcement and create an insane amount of redundant material, because the more redundancy there is, the more you're going to get bored of reading always the same things that you already caught up, okay? And the one thing that you miss, you are going to probably overlook it in the announcement, in the middle of all those things that are repeated that you already knew from the lecture. So this is why, again, us investing in making those forums, sort of a learning community is going to pay off, because that's the best way, by interacting with other people, to have a non-boring way, a non-redundant way, or not as redundant way, to actually make sure that we double check that you caught everything about the lecture, okay? So this was to try to make you understand, how great it can be to have a community of learning on those forums. Now, some semesters, students love the forums and we have a ton of activity there. Some semesters, everybody is shy, nobody wants to make the first step, and we have very low activity. It's a bad thing. I think it's a bad thing for your learning, but I will not force you, I will not make you uncomfortable and single you out and force you to make posts, if you don't feel like. I'm just advising you regarding what I think is the best practice, for you to get the most out of this class, okay? It's not because it's an online class that you don't have an instructor ready to answer your question and that you don't have other students that you can also discuss with, okay? So let's try to foster communication as much as we can. You are going to have some practice. The form of this practice is going to change from module to module. So what I mean by practice is, in some modules where we talk a lot about concept, maybe I will have a quick graded quiz. So you'll take your quiz maybe in 10 minutes, half an hour, just a few questions, multiple choice, fill the blank, that kind of stuff, just to make sure you understand the concept, okay? So for some topics, a quiz is the best way to test you on the concept. For other topics, maybe it's going to be a small exercise, like write a Java program similar to the one we discussed in slide 23, and do this and this and this and this with it, and then submit it, okay? So the nature of the practice assignments is going to change from module to module. I'm going to always try to go with what's the most useful, okay? Every time you have such an assignment, I will make sure that I mention it in the lecture, that I explain it, and that I post, an announcement on Canvas to let you know that there is a new quiz or a new homework that has been released and that is going to have to be submitted by this date, okay? So I'll try to always have some sort of announcement that documents, what is due when, what has been just released, and stuff like that. If you go to the syllabus section of Canvas, you are going to see that you will have everything that is assigned to you appear there as a link, and the due date is going to be next to it. So it's very, very easy to see what's coming up, what's going to be due soon by just going to the syllabus page in Canvas. And again, if you have any question about that kind of stuff, don't hesitate. We have a support forum that for any possible problem you may have with Canvas or with software, just go there and say, I'm not sure I'm reading that right in Canvas. I see that homework 5 is due in 3 weeks, is that correct? Or, am I misreading it? Whatever. Don't hesitate. You have a problem, reach out. Another thing we are going to have to do, and this is actually this is a typo. This is a wrong title for that slide, okay? So case study, that's correct. The other type of assignment we're going to have in this course to help you make the most out of the course is a case study. So there's going to be one case study assignment. The detail will be posted when I release it. I generally release it a few weeks into the semester after we are done with the introduction, the review of Java object-oriented programming. And it's pretty much a way for you to take a selection of topics that we covered in this class. Like, for example, metaprogramming in Java, generic programming in Java. And then you are going to be able to choose a language that you really like, or that you're curious about, or maybe that you're already using at work. So you're going to have a choice here in picking a programming language different than Java. And the whole point of the case study will be for you to mimic the stuff that we covered in the slide, in the lecture, and apply it to that language. So for example, if I teach you how to do metaprogramming in Java, and I show you how to, for example, obtain the name of the class from an object, well, then I will ask you to take the language that you chose, do a little bit of research, and come up with a documentation that explains how you are able to do exactly the same thing in the language that you chose. Okay? So the case study allows you to better understand what we study in this class by trying to apply it by analogy to another programming language. So it's a good thing for you to go through that's why it's a semester-long assignment. It's a good thing for you to go through each part of the case study as we cover the corresponding part in class. So when we do metaprogramming in Java, you should write up the part of your case study that's going to say, for example, how do I apply this to, I don't know, for example, JavaScript, okay? Or Python or Ruby. So this is going to be the first benefit of the case study. The second benefit of the case study is that you are going to be able to have access eventually to the case study of other students in the course. So you are going to get not only to go outside of the Java universe and apply what you learn, to another language, but you are going to also be able to see what other students did with completely different language, maybe a language that you didn't want to choose for your own case study, but you're still a little curious about it, okay? So that's going to be the way that I mentioned at the beginning of this video that we were going to be really focused on Java. Well, yes, we focus on one language and we try to do it thoroughly, okay? As opposed to jumping right and left to different languages and studying none of them seriously. But at the same time, I use a case study as a way to open wider your horizon as people that study programming techniques. And I enable you pretty much to get a taste, to get a feel about how things are going in completely different languages. Okay? So again, I'm going to post more detail about that, okay? This is just to give you an overview of what to expect in this course. And then we'll have exams. So we'll have 2 midterm exams. We are going to have 1 final. The final is definitely comprehensive. The midterm, by definition, are comprehensive for all the material covered until that midterm, okay? Time limited. Every midterm is time limited. You have a single attempt to take them. So it's not a kind of deal where you take each midterm 5 times over the course of a week. No, you sit down. You have maybe, I don't know, 2 hours, 1 hour to take, you know, your midterm, and from the moment you click, you have 1 hour to complete it, and you cannot reopen it later. That's pretty much what it means, okay? So those exams are going to be online. I think it's suitable because this is an online class. So I know that some of you have very difficult schedules. Some of you are geographically dispersed and you're not anywhere near the campus. So I'm trying to accommodate you by making the exam online. The exams are going to be open book, because I generally don't test your memory. I test your ability to understand what you studied and apply to new problems. So be careful, okay? Apply to new problems. It's open book, so I'm not going to ask you to do the same thing that we did in the slide, okay? A lot of students say, well, you know, I was expecting something closer to what's in the slide, but yes, with an open book exam, I'm not testing your ability to copy, right? To photocopy the slide or to type what's on the slide. I want you to think and to solve problem. And so I'm going to present to you a new problem that is related to what we did in class and measure your ability to apply what you learned to solve that problem. The IDE will be allowed. So these are hands-on exam. I can ask you in an exam, for example, to write a piece of code in a Java file and then upload that Java file to Canvas. And it's not because it's online that it's going to be, you know, everything goes. We are going to use the Proctorio software, see syllabus for detail, to monitor you. Monitor you means it's going to force you to use a one screen only. So if you have a multiple monitor setup, you'll have to set that up so that you use only one screen. It's going to monitor your web traffic. It's going to do all sort of things there to actually ensure that you're not cheating, okay? And obviously, open book and IDE allowed, still no browsing allowed. Google, not allowed, okay? Going on forum, ask question, not allowed. Searching forum for people that ask already your question, not allowed. Any form of seeking external help, talking to people in your room, calling them on the phone, all of those are examples, chatting with them online. No, this is personal work, and this is very important, okay? If you are caught cheating in one of those exams, I have zero tolerance for this kind of behavior. I think this is only respectful on behalf of all the students who work hard and try actually to earn their grade. If I catch any one of you cheating or sharing solution to one of the exam, this is going to be a double F immediately assigned to everybody involved. So for example, if somebody asks you for help or asks you what you submitted to the exam and you share it with you, it's your fault. You have been warned. You are going to be involved in a cheating attempt. As such, you are going to receive also a double F. And double F means failure of a course for academic dishonesty that stays on your transcript and that really doesn't look good. So I really hope that we are going to have an incident-free semester and that I would not have to deal with this kind of situation. But if I am forced to deal with this kind of situation, I want to warn you fairly ahead of time that there will be zero tolerance, okay? So let's keep that in mind. Only submit personal work. And if you have a legitimate question about, you know, well, does open book mean that I can, for example, also have access to the exercise that I wrote, you know, when I was studying the slides, then ask that question on the forum. I will gladly answer it, clarify for everybody, so that everybody can come to the exam, you know, fully prepared and with access to all the legitimate resources they are entitled to have. So I mentioned Proctorio. A quick word about Proctorio. You are going to have to use Google Chrome and Google Chrome only when you interact with Canvas and take your exams, okay? This is the browser for which both Canvas and Proctorio are guaranteed to work 100%. The first time, you will have to set up Proctorio. Set up Proctorio means that Proctorio runs inside of Canvas, but it also requires you to have a Google Chrome add-on. So it will prompt you to install it and you'll go through that setup, okay? So if I remember correctly, the first week quiz, which I'm going to talk about in a few slides, is going to be Proctorio enabled. So that's going to be a good way to test out that Proctorio is working on your browser. Don't be surprised if Proctorio asks you to show your student ID to your webcam. So you need a webcam, you need a microphone to be able to take those exams, okay? So it's going to test to make sure that you have your ID and show it to the webcam to confirm your identity. Like I said, use a single monitor, a single screen, and your network traffic, your screen, the content of your screens, the audio in the room, the video from the webcam, all will be recorded. If you try to put a sticker on your video or, turn off the microphone or somehow obfuscate, what's going on to hide something from Proctorio, I'm not going to even grade your exam. You get a 0 directly. Okay, that's it. That's the end of the story. The point is that Proctorio is the equivalent of a proctor if you were taking an exam on campus. It's going to apply AI algorithm to all of those recording and detect automatically cheating attempts, okay? So it's going to raise flags. I'm going to investigate the flag by hand. And if there is indeed, it's not a false positive, then this is where we are going to assign you, a FF for academic dishonesty. So take this seriously. Again, this is not because it's online that it should be any less rigorous than any other USF course. A question that comes up very often, actually. What if my ISP is unreliable? Let's say you open an exam. It's 2 p.m. You click on your exam, you open it. You have, let's say, 1 hour to complete it. If you get kicked out of Blackboard, generally Canvas is really good at detecting that. So it will allow you to reopen the exam. But the key is, if you started your exam at 2 p.m., and you have only 1 hour to do it, then at 3 p.m., you need to submit your final answer for the exam. You cannot be disconnected, disappear for half an hour, and then come back. If you get disconnected, reconnect immediately. If you fail to do so, if you fail to send me an email right there and tell me what happened, then there's not going to be any sort of makeup of the exam, etc. Yes, technology is unreliable, and as technology professional, we have to learn to actually ensure that we know how to use technology and know how to make up for its inherent unreliability. So what does that mean? That means that if you have an ISP at home that is really cutting you off every other day, you should not take an exam online. There are other solutions. You can work with the testing services at USF. So make a search on the USF website for testing service, and you can come on campus, and they will have a quiet environment with access to wireless internet on campus. So if the wireless goes down on campus, we can actually document that. If we can document it officially, then we'll have a makeup exam or something like that. But if your ISP goes offline for like 10 minutes and you tell me, well, I need to retake my exam, no, we cannot grant stuff like that for things that cannot be formally documented and verified. Okay? Otherwise, it's just an easy way for you to open an exam, look at the question, say, oh, wow, I'm not ready. Turn off the internet on your home, and then come back, 2 days later and say, oh, by the way, can I get another exam? No, that's not going to work, okay? So use USF testing services if you have an unreliable internet connection. That's one possibility. If you are not living close to campus, we can work out something with testing centers. Again, contact USF testing services, see what they have to say and what they can do to accommodate you. Okay, so it's a very good option for online classes. I really recommend that you look into it. Frequently asked question again related to exam, how's the grading? Well, the grading is meant to reward knowledge and understanding, deep understanding of the topics at hand. So when you look at your grade, by all means, you are very encouraged, to look in the details of the feedback. And if you feel like, I misunderstood something or I misgraded something, or don't hesitate to contact me. That's not the problem, okay? What I mean by no extra credit / no negotiation between quote is that if there is a grading error, it will be my priority to fix it. I don't want you to lose a single point due to a mistake on my part, a misunderstanding, or something like that. However, you have to distinguish that from grade negotiation. So if you come to me and you say, you tell me my program doesn't compile, but I just compiled it on my computer, can you take another loop? I will be happy and glad to do so. This is an objective complaint, okay? This is like a concern that can be validated, verified. So that is perfect. You know, come to me, we'll work it out, we'll figure it out, and I will make sure that your grade doesn't suffer from anything that is at fault on my side. Now, distinguish this very clearly from coming to me and saying, well, I thought I would get a better grade, or, you know, yes, I misunderstood the topic, but given my understanding of your question, my answer is right. We are opening the door here to very subjective stuff, right? I feel like you should give me more points, or I believe that, you know, you should not remove 2 points for this mistake. That is what I call negotiation, okay? Deciding how many points are removed for every type of error is not a student prerogative. This is an instructor prerogative. Okay, as such, we are not going to open a dialogue on this kind of topics. But again, I want to insist on that, we are going to open the dialogue every time you think there is a mistake in the grading to make sure that actually your grade reflects your understanding of the question, reflects your understanding of the study material, and your ability to apply it. So notice that I mentioned that it reflects your understanding of the question. If you do not understand any of the question or most of the question in an exam, this is not normal to get a low grade. Okay, it's the same way that if your employer comes to you every Monday morning, assign you some work, and you spend the whole week doing something completely different, after 2 weeks of that, you're going to probably find yourself on the soon-to-be-fired list. That's part of being actually able to work in a field to understand question, even difficult one. Okay, so the grade other than that is going to always try to reward deep understanding. What I mean by deep understanding, I essentially want to contrast it from, you know, rote memorization. I don't want you to memorize things from the slide and fill your memory with this kind of knowledge and then come to the exam and just regurgitate it, okay? If I wanted to do that, I would not allow for open book exams. So as you can guess, you have open book exam, but that means that before the exam, you need to really study and understand the content and ask me questions and practice and so on and so forth, so that by the time the exam comes, you're capable to generalize that knowledge and adapt to new problems, just like you're going to be expected to do in your future job. We're almost done. Let's go through the to-do list for the first week. Okay, so this is kind of a summary of everything that you need to do during this first week of this online class. Don't hesitate to get help by posting on the forum. Okay, anytime. There's no such thing as asking questions too early, or, you know, asking questions that are too trivial. Anything that bothers you, put it there, and I will jump in and help you out. So task 1, install the software that we are using. So we are going to use Java 8 in this class. This is not the latest version of Java. The latest version of Java at the time of this recording is Java 9, okay? We are using Java 8 here because we focus on functional programming. So all the features of Java 8 are also present in Java 9, but we're not going to look at the modularity feature, for example, for Java 9. So that's why I recommend that you install the Java 8 JDK. Java Software Development Kit, okay? Not the JRE. When you go to download Java, you're going to be offered to download the Java runtime environment. This is only for people who want to be able to run Java code on their machine, okay? This is not what we need. You need the JDK, which is a Java Software Development Kit, which allows you to have all the library that a programmer needs to develop Java application on their machine, okay? So before you even install Java, I really suggest that you clean up your system, because this is a source of a lot of problem. So here's a link from java.com that's going to allow you to detect all the old version of Java you might have. It will help you remove them, make place, so that then you can go here and download the JDK 8 from Java and install it on your machine. If you bump into a problem while doing so, come to office hours, okay? That's the easiest way to fix those kind of problems, is to interact with one another live, or set up an appointment for an online meeting if necessary. As far as integrated development environment, I recommend that you download JGrasp, okay? Here's a link. And so if you took already classes like COP2512 and COP2513 with me, you are familiar with JGrasp, okay? And here's a little YouTube video to help you make sure that you install JGrasp and it's working properly and it's working with your Java installation as well. So this is what I would suggest if you don't want to be bothered by a complicated IDE. JGrasp is an educational IDE. It's used in Introduction to Programming. It's very easygoing. We're not going to use any fancy feature and make any sort of project, you know. We're just going to write Java code in Java files, compile them, and run them. So JGrasp is all you need for this class. However, I know that some of you have already had experience with professional integrated development environment. NetBeans, Eclipse, IntelliJ IDE. If you want to use them, this is an elective, okay? This is an advanced Java class. So by all means, I will not prevent you from using them. Use what you are familiar with. Use what works best for you. However, let me point out a few things that have been problems for other students in previous semester. We are using a specific JDK, so make sure that you know how to set up your IDE to use that JDK. Make sure that you know how to use the IDE that you chose fluently. If you are not comfortable with NetBeans, Eclipse, or IntelliJ IDE, use JGrasp. This is the one for which I'm going to provide support in this class. If you come to me and you say, well, I set up a project in Eclipse, but now it's not compiling and it's asking me some question about Maven, no, we're not going to cover that in the class. So I'm just giving you an opportunity to use an IDE that you already know how to use fluently, if you prefer, okay? But at the same time, if you have problem using those IDE, I will always refer you back to, okay, then install JGrasp and use that instead. It's much simpler. Do not waste your time fighting the IDE. If you know how to use an IDE, an advanced IDE, and you like it, and it helps you save time, by all means, be my guest. If it doesn't save you time and it causes you more headache, then use JGrasp. And last but not least, because this is actually a problem that happened in a previous Java course where I allowed students to use the IDE of their choice, if you are using one of those advanced IDE, you have to be aware that they are going to do things their way. So with JGrasp, it's easy. You open a folder, you put your Java file in that folder, this is where you find the Java file. With NetBeans, Eclipse, and IntelliJ IDE, if I give you a Java file in an exam and I ask you, for example, to do the job that is described in comments in that Java file, you need to be able to take this Java file, download it from Canvas, insert it into a project inside your IDE, and then, you know, work on it, and finally find the Java file that was modified by your IDE and submit that one. I know it sounds trivial, but I've had students in the past who ended up resubmitting the file they downloaded because they didn't realize the IDE made a copy of that file and made that copy, moved that copy to a different folder, and so they worked for an hour on a file and then they submitted something different. So again, it goes back to, you know, if you want to use an advanced IDE, this is not a class about teaching you to use an advanced IDE, so you need to already be comfortable with it. Otherwise, JGrasp is your friend. Task number 2. Very important. By Friday at 1 p.m., you need to take the first week quiz. So the link is going to be available in the syllabus section of Canvas. Okay, you're going to see first week quiz and deadline the Friday of the first week at 1 p.m. Click on it, take it. And not only you have to take it before the deadline, but you have to score 100% of the point. To do so, you can retake it as many times as you need. This is the only time in this course where you have a quiz, you know, something like that, where you can keep retaking it until you get it right. The idea of this quiz, don't freak out. It's not to test your knowledge of programming before we even have a chance to teach you programming. No, the idea of this quiz is really to just, it's just a glorified checklist where you are going to say, yes, I got my textbook. Yes, I am done installing the software. Yes, I read the syllabus. And pretty much I can tell you already as a way of cheating, all the answers are yes for that quiz, if I remember correctly. However, don't answer yes if you didn't do the corresponding item. That defeats the whole purpose. It's just a way for us to make sure that you abide by the term of the syllabus and that you understand everything that you had to do during the first week and that you are ready to start working during the second week with everything functioning and ready on your computer. So That means that you should probably take this after you're done installing the software and testing it and making sure it's working. And once you do that, retake it as many times as you need until you get 100% of the point. Use a gradebook to see how many points you get every time you attempt it, and it's going to tell you got, for example, 6 points out of 7. Well, then you need to go reopen the quiz. It's going to show you what you got wrong, and keep at it until you get 100% of the point. On Friday, shortly after 1 p.m., I will automatically use a gradebook to mark as present every student who obtains the maximum score. So everybody who took the quiz by the deadline and scored 100% of the point is marked present for the sake of first day attendance. And everybody who didn't take the quiz or didn't score 100% of the point is marked as absent. So that doesn't mean that you are dropped out of the course. It's a very ambiguous issue, so I'm going to warn you about this. Essentially, you are going to be dropped from Canvas if you didn't comply with that first week quiz, policy. So like if you didn't show up on the first day of class and we took attendance, that's the point. However, some students reported to me that even though they have been dropped from Canvas, they have not been dropped officially from the course. So if you intend actually to drop the course, like you listen to this video, you say, the selective is not for me, then I really suggest that you work with an academic advisor and the registrar to properly drop from the course so that you're not charged for this course, okay? Simply not taking the first week quiz is not enough to process a full drop, okay? But it's enough to kick you out of Canvas, and pretty much you're not going to be able to access the material, and you are going to be considered, as non-present for the first day of class. So you won't be able to come back to the course, okay? So be careful about that. A lot of administrative stuff, and if we can spare ourselves extra paperwork, that's great. Next section, we're going to talk about how to get help in this course. So it's an online course, but I really want you to understand that you are not alone in this course. There are other students with whom you can interact, and there is myself, your instructor, with whom I really hope you're going to interact, okay? Meet me during office hour, meet me online, post on the forum, drop me emails for personal matters and stuff like that, okay? So don't make the mistake to assume that, oh, I'm just getting those videos and those quiz once in a while and that's all there is to it. No, it's a course that requires a lot of work, but there is a support system, so use it. The first level of support is Canvas Forum. So anything that is non-graded. You have a question about an exam. You have a question about your grade at that exam, the feedback you got on your grade. All of that never goes to the forums. Same thing if you have personal problems, okay, that you need to discuss. This is a public forum. Never post any of this on the forum. What you should post on the forum is question about the lectures, the video lectures, the reading assignment, so any of the study material. And like I already mentioned, try to get into that peer learning thing, okay? Because that will help you first, and that will help create that community of learning that's going to make this course so much more pleasant for everybody, and at the same time so much more, convivial for you. You're not going to feel like you are alone studying in your corner. Emails. Yes, feel free to email me at alessio@usf.edu. Okay, so this is slightly different from the format of the student email. That's the only email that's going to reach me safely. So don't use something like alessio@mail.usf.edu. No, that will not work. Use alessio@usf.edu. I would really recommend that you post questions about study material on the forum, so that we can all, discuss them together. And then you save emails for personal matters. So personal matters can be a personal problem, can be question about your grade, question about the feedback you got at an assignment or an exam, question about, should I do this or that at the exam. All this kind of stuff, is what I would consider personal or related to graded stuff. So yes, it's appropriate by email. I'm generally very fast at responding to email during business days. If you don't hear from me within 24-hour business time, I would say your email got stuck in a spam filter. It doesn't happen often, but I've had students use their USF official email address, which is what you should use when you email me, and still get caught in a spam folder. So if you don't hear from me within 24 hours, drop me a Canvas message, Okay, between Canvas message and emails, you should be able to reach me, and I really respond fast generally, so don't let an email just drop and assume that I'm not responding to you. I never not respond to a student, okay? Office hours, so there are office hours on campus. Tuesday, Thursday, noon to 2 p.m. is what is set up for this semester. This is the name of my office. Feel free to come. These are just walking, no appointment necessary. You can come a group of students. If you have been studying the study material with a few classmates, you can come a bunch of you. Only word of warning, this is not a big office. If there's more than 2 of you at the same time, then it's going to be either there's a queue in the hall or we have to find a bigger room. So if you give me a heads up, you say, hey, I would like to come with 3 other classmates with whom I've been studying to your office hour this Thursday. You give me at least 2 days heads up so that I can try to book us a larger room and we will meet there, okay? So study group, very good. Just give me a heads up for logistic reasons. This is a screenshot of a Canvas site for a course, doesn't matter which one. I want to draw your attention to Blackboard Collaborate Ultra. Because this is an online class, I don't expect all of you to be able to make it to campus office hour. If you need to meet me, but you cannot make it to campus, drop me an email and ask me for an appointment, okay? And we are going to use Blackboard Collaborate Ultra. So when you click on that link here, you're going to see this page. You have a course room that is a default virtual room for us to meet. You click on join room and we are going to be able to do live video conference and even share desktop and stuff like that. So it's just as good as live, you know, face-to-face meetings. It's live online, and it's really an easy way to solve problem. We can sometime have a quick session, half an hour, 10 minutes even, just clarify something, address your question, and then you're good to go. Whereas if we try to do that by emails or forums, sometimes it can get complicated. Not everything is easily solvable by forums and emails, okay? So that's another option for us to consider. Phone, very bad idea, just avoid altogether. I'm really awful about that. I think my phone is still blinking red from time to time in my office. I don't know what it wants. Emails are definitely the best way to get a hold of me, or Canvas message, okay? And I will check the forums. Normally I check them once every day during the business week, okay? So if I see a post, I generally answer it within 24 hours. A few details about common mistakes that students have made in this class before and that I want to spare you. So use the available help early and often. Okay, very important. You wait for the last minute to get help, you're not going to be able to leverage it. Okay, you ask one question during the whole semester, you are not, you know, you're not making, you're not benefiting from everything that's there to help you. Okay, we just went over everything that's available to help you. These are resources. Use them to maximize your understanding of the material and therefore your grade. Okay, so that's in a nutshell the idea of that slide. The example I want you to absolutely avoid is, and this happened many times, typical student who attends actually lecture. So in an online class, that means that you watch a video one time, but that's it, you just watch it one time, you don't really study it, don't ask questions, you don't play with the code example, and then 1 week before the exam, 1 week happened by the way, but generally it's 2 or 3 weeks before the final, the student come and say, I really need to pass this course, you know, but I'm not ready, what can we do? And the answer, unfortunately, most of the time is nothing. We cannot do anything because you waited way too late. If there was a way for me to impart to you all the knowledge of this course in 2 weeks, yeah, we would probably do that. I mean, USF would probably be happy for us to have 2-week-long courses where we just transfer all that knowledge, you know, very efficiently in your brains, and then that's it. The whole semester is 2 weeks, so USF can offer 8 different semesters instead of 1 semester, make, you know, even more course available and stuff like that. So no, there's no magic fix. It takes actually 16 weeks to go through this course. We build up progressively difficulty. We give ourselves time to absorb the knowledge, think about it, reflect on it, ask questions, practice it, etc. If you lose all of that time, you know, because you don't ask questions, then at the last minute, there's really nothing we can do. Okay, it's not one of those courses where you can cram at the last minute. Other thing to be really careful about, if you have problem with programming, like serious problem, you cannot write a program, you barely pass the prerequisite classes and stuff like that, this is going to be a huge issue in this course, okay? I want you to be aware of that. So what do I mean by programming? Well, programming means programming knowledge. So for example, you should either know the Java language syntax, the basic syntax at least, you know, for loop, if statement, method, how to write a class, how to make attributes public, private, that kind of basic stuff, okay? Formal parameter, effective parameters. So the stuff that you generally study in COP2512 and COP2513. So either you know that stuff already, or you have studied a different language in those classes, but you are comfortable enough with programming that you can open a book on Java and say, okay, so this is how you do a for loop in Java. Well, you know, there's not many differences, so you should be able to make that jump. So anything from procedural control flow, how to use loops, if statement, recursion, methods, arrays, all of that should be already in your tool set. So if any of that feels, you know, really bad, chat with me. Let's figure out, you know, how prepared you are and stuff like that. And then there are programming skills. For some student, depending on who you had, you know, in those introductory programming class, the instructor that you had made the assumption that it's the same thing to know to read programs or retype programs that are exactly like the one in the slide to answer a question that is exactly like the one in the lecture. And they made the assumption that, or they led you to believe that this is programming. This is not programming at all. Programming is the ability for you to use all of the tools made available to you by the language, so loops, method, recursion, classes, to solve and write a program from scratch, to solve, autonomously, meaning by yourself, a small computing problem. So you have to be able to write a small piece of code, like maybe 50 lines, I don't know, 100 lines, maybe if you have enough time. This is a scope of what I expect of you to be able to do. If you have problems with that, let's talk as soon as possible during the first week. So we figure out if, you know, you are still in shape to start that elective, or if you need a little bit extra preparation. Now, if you need a little bit extra preparation, you don't necessarily have to drop the course. Okay, that would be an extreme solution if nothing else works. But if you are capable to actually, you know, dig back into Java on your own, you know, while we do this little Java review, then you should be able to hang in this elective. So what I would recommend, here are a few resources that I can point you to. This textbook here is what we use for both COP2512 and 2513 when I teach them, okay? And these two courses are pretty much the ideal prelude, you know, for this elective. So you can find, if you want to have access to a version of those courses, you can go to those URL. You're going to see there's an online version of each of those courses. You can use that to take a look at the topics we covered. You can go and borrow the textbook from library or an old edition, even find an old edition elsewhere and use it as a way to quickly refresh your memory about things you might have forgotten about Java, okay? And we are going to also make a quick review on Java Essential during the next session, okay? So there are like at least 3 different resources there to help you during the next 2 weeks, the next week and a half, as we review Java fundamental, to help you, you know, come back up to speed. Sometimes you just took Java long ago, like a year and a half ago, you don't remember it. Okay, this is why we have this time in the course for you to catch up. But you need to be aware that you need this kind of refresher, and these are just some options for you to do some additional study on the side, you know, before we start attacking the hard topics, the difficult stuff. Another clarification that, again, has been relevant many semesters, the difference between studying, teaching, and evaluating. Very fundamental for you to understand. Studying, I already mentioned that it's not just, you know, listening to a video or reading a book. No, studying means that you are putting in some work, some focus, some energy that helps you understand the new material, techniques, or technology that are presented to you in the study material. Now, teaching means that you get help while you study, okay? So this time, it's me producing the effort to understand what is causing you trouble, discuss with you, interact with you, and help you out. But that means interaction, right? Teaching doesn't mean that I made the video so that nobody will ever have any question on the video. Everybody is going to watch the video, and students come up with very different things that they don't understand, very different questions from one another, and that's how it works. So my role in presenting to you the video is to be as complete as possible, as thorough as possible, okay, and make sure that I present the material clearly. And then my job is to interact with you and meet with you and make sure that I help you understand. But if you come to me and you say, I listened to the video one time and I don't understand it, well, we have nothing to work on, okay? Part of learning to be a student and learning to learn is for you to be able to say, okay, when I listen to this video, I understand everything up to slide number 30. And then when you explain, the difference between inheritance and aggregation, I'm lost. Now we can work with that. And that shows me that you put in the work actually to understand everything you could in the video up to the moment where something threw you off. And just identifying when you get, confused is tremendously important in us establishing that teaching and learning dialogue, okay? Just saying, hey, the topic for this week is hard. I don't understand it. Well, that's not studying. And if you don't do the studying, there's no teaching that can go on top of that except me pretty much making another lecture, and then another lecture, and then another lecture. And then if you look at all the lectures superficially, then you will never understand, okay? So the dialogue, the didactic dialogue as they call it, is really essential to not only helping you get better, but saving you time so that you're not stuck on a problem all by yourself for a long duration of time. And then I want to separate this studying and teaching, which is a fun part. It should be the fun part for you. It is definitely the fun part for me to interact with students and help them understand, see them improve. But that's the nice part, right? That's Dr. Jekyll. And then we have Mr. Hyde. And Mr. Hyde is, now you step into an exam room or you click on an exam link online and you are being evaluated. So imagine that you want to get a certification in IT. You study. Maybe you have a bunch of study buddies, maybe you have a tutor, maybe you are taking a course. Everybody is trying to help you understand the material. This is great. And then you step into the exam room. This is not the time to ask the proctor, oh, I see you have a question on this topic. Well, I never quite understood it. Can you give me the brief summary? No, that has nothing to do with studying. That has nothing to do with teaching. You are not actually being a student when you do that. You are being an examinee, somebody who is taking an exam, who realizes they're not ready and is trying to get somebody else to provide them either all the answer or part of the answer or help them answer the question. No, when you take the exam, you are being evaluated. This is where we determine whether your studying has been fruitful or not. And this is not the time for you to ask those kind of questions. You are not going to get help while you are being evaluated in an exam. Okay, so make sure you understand the difference between again, like the fun part and the friendly part of studying and teaching, and then the rigorous part of, do you meet the standard that allow you to, go out there, apply for a job, bearing like a degree from USF and our department without embarrassing yourself and our department in the process. Okay, two different things. All right, if we were face-to-face, I would say this is question time. Okay, we are not face-to-face, so this is going to be a little bit more asynchronous, but it's a good time for you to, well, take a break. This was a long video, obviously, but you have the whole week to watch it, so hopefully you did that in several chunks. And it's time for you to go on the syllabus forum to post any question you might have about this overview video. As you were, I'm sure, writing down on a piece of paper, I don't know what it means there, or does that mean I can do this or this in the exam? Well, all of those thoughts, if you didn't pause the video and ask them right away, then now is the time. Go to the forum, start the discussion, the earlier the better. And once again, welcome to that elective. I hope you are going to have a great time learning about those programming techniques. Programming is actually very fun. Can be challenging at times, but it's a very fun intellectual endeavor. And I hope that the content of the elective will support well your career, your future career in IT or cybersecurity. Thank you again for listening to this video, and I look forward to interacting with you in person, by email, online meetings, or even just on the forum.